Today we are going to carry out 4 experiments.
They are newspaper with electricity,
The magic water
gasoline turn water into ice,
and the formation of pebble.
First experiment is newspaper with electricity. Do you know how newspaper can stick on the wall without any glue? Let me explain for you. Actually, we need to prepare a piece of paper and a pencil. Then open the newspaper and put on the wall. Next, take a pencil and rub the newspaper deeply. Now you can see the newspaper stick on the wall. You set off the corner of the newspaper and let it go. The corner will stick on the wall again.
Everyone's had that moment where they walk across their carpet and reach for a door handle only to be greeted by an irritating shock. This phenomenon is known as static electricity, and a more drastic example can be seen when lightning occurs. Although chemists and physicists are unsure of how exactly static electricity works, many theories have sprouted as the scientific importance of static electricity and its implications continue to grow. Static electricity is also known as triboelectricity, or rubbing amber, due to Thias of Miletus discovering an electric charge occurring after rubbing amber with wool. However, we know today that static electricity does not only occur through frictional contact. Just touching is sufficient for static electricity to be initiated, and for static electricity to occur, there needs to be an imbalance of charge in a material that remains until it can be balanced. So what happens when you walk across a carpet that gives you electric shock when metal is touched? When you walk across a surface, you're causing a transfer of electrons to occur, since contact between you and the floor initiates a chemical reaction that allows the more electronegative material to take electrons. You can magnify the extent of the transfer of electrons by wearing sock material that tends to give up more electrons, such as wool. Triboelectric series charts show materials that tend to give up more electrons on top and materials that tend to take electrons on the bottom. Once you give up some electrons, which have a negative charge, to the floor material, you're positively charged. As soon as you touch metal, which readily gives up electrons, electrons flood through skin contact to balance out the positive charged atoms and you receive an electric spark. This cannot happen when you're wearing polyester or rubber materials on your feet, since these materials tend to take electrons through floor contact and will not need to take any more from touched metal. Additionally, the loss of electrons causes hair to stand, due to repulsion between the hair strands from the increase in positivity. This is similar to two positive sides of a magnet repelling. You can even take a balloon, rub it on your hair so it gains electrons, and temporarily stick it to a wall as electrons attempt to cross over to the wall and, in doing so, pin the balloon. Static electricity also occurs between the ground and clouds during lightning, where particles touching within clouds generate static electricity, and the temperature at the point of electron transfer, or a thunderbolt, can reach over 50,000 degrees Fahrenheit.
you the answer. In this experiment, we need to prepare a glass of water and a piece of paper. Firstly, fill out the glass with water. Then cover the glass with a piece of paper. Upside down the glass by pressing this paper. After a few seconds, remove your hand. Finally, the water does not fall down. Let us show you. First, we need a bottle of distilled water, a bowl, and some ice. Put the bottle of the distilled water into the freezer. Make sure the temperature is below 24 degrees Celsius. Take out the distilled water slowly.
How to turn water into ice without a freezer. See water freeze before your eyes with the magic of physics. You will need a cup, water, a bell jar, and a vacuum pump. Optional, acetone. Step 1. Fill the cup with water. Use equal parts acetone and water to speed the process. Step 2. Place the cup inside the bell jar. Step 3. Connect the bell jar to the vacuum pump and turn it on. Step 4. Watch the water begin to bubble. Step 5. Watch the water turn into ice as the warmer molecules escape into the vacuum and the cooler molecules clump together to form ice in the cup. Did you know? The lower the air pressure, the lower the boiling point of water. If the pressure is low enough, water will boil at room temperature.
Rainbow after raining, but now we want to prove that we can also see a